All right, so what did we do on Tuesday? We looked at basic graphs and circles. The rectangular coordinate system. Spelled it correctly this time. And graphing and circles. So let's see. It's just want to jump into some graphs. I think that's the easier way to go. Let's do y equals 3x plus 5. Let's do it by picking points. If you know another way, don't do it yet. Sometimes you don't have that option, and it's worth having practice in picking points. You see them off the screen. So unless you have a good reason otherwise, and we will get to good reasons otherwise next week, you kind of want to center your graph around 0. And we're going to evaluate each of the points we pick around 0 in the equation. So if I stick in -2, I've got y equals 3 times -2 plus 5. So my ordered pair will be -2. And 3 times -2 is -6, plus 5 is -1. If I stick in -1, I got -1. It's my x component. 3 times -1 is -3, plus 5 is +2. If I stick in 0, this gets easy. It's just that last number, 5. And I'm going to do that for each of these. You'll notice that as we go one step in x, this is going up by 3. So I can speed this up a little bit by just doing this and not having to do the calculations. Each increment goes by +3 as this increment goes by +1. And it has very much to do with that 3 right there. And we'll cover that today. It's called the rate of change. Now that we've got some points, though, we could graph this.
Don't we also usually want to find where y equals 0?
We can. It's a good choice. I didn't do it here just because it's going to give me a fraction, but we can. We can say, where does y equal 0? We do that, we've got 3x plus 5 equals 0. And we're going to get x equals -5/3. So that'll give us another point. You generally don't need this many points unless you're wanting to verify something, or at least for a straight line when there's no exponent on the x or the y. That's what makes this a linear equation. This is a line because y is to the first power and x is to the first power. And we call them linear equations. When I'm hand drawing my graph, I tend to like look at the total width of like my numbers. How far is x going between, it's going from -2 to 2. How far is y going? It's going from -1 to 11. So I made my y-axis up top much longer than I did below because I didn't need a long one below. So I use the points over here to guide me. And we start following these are the x and y coordinates. So it's literally what you do with these is you start at the origin or this where the axes cross, and if it's negative, you go left to right by the first number and up and down by the second number. If it's negative, you go left. If it's positive, you go right. So starting here, and I'm going to do -2, -1. I'm going to go left 2 because the 2 is negative, and we go down 1 because the 1 is negative. I'll do the same thing for the next one, -1 and 2. I go to the left or right first, the 1 is negative, so I'm going to go left 1. And then from there, the 2 is positive, so I'm going to go up 2. And that -5/3 looks like it's right there. -5/3, 0. If I keep going, 0, 5 means I don't go left or right. 0, no left or right movement, just up 5 steps. And if I keep following along this pattern, I will notice that as I go right 1, I go up 3. So I'm going right 1 and up 3. This is related to the 3 up front. 3 up front equals 3 over 1, which is a positive 3 over a positive 1, which tells me to go up 3 and right 1. That'll hold true for any fraction that we do. And now I connect the dots. And if I had done my table any better, this would look like a straight line, but it doesn't look like a straight line, does it? Looks better on graph paper. Jones wrecked that actually. Any questions? Chris, Senzi, Paxton? All good?
All good.
All right, let me give you guys one to try.
How many points did you want us to do?
I would do 5 for now. Just get some practice in right now. I will probably ask for less when we get to a test. But I don't know. It's good practice. You actually do this a lot in trigonometry, you do it in calculus, you evaluate functions or equations at their given values. So it's a good skill to be practiced up on. All right, let's start taking a look at values. I definitely want 0 on the list. I could put -1 and -2 and +1 and +2 like I did last time. But I think you're not gonna like the results because of that fraction. So it's a good idea, if you didn't do it, you've learned how hard it was, what a pain in the ass it was, to work with like -1 or +1. Use numbers that will cancel out that denominator. So rather than going -1 and -2 and then 1 and 2, I'm gonna go -2 and -4. Even numbers will cancel out that denominator. And then I don't have fractions, and then it makes it easier to graph. Did anyone do that? Or did anyone else just do all like -2, -1?
I did -1.
Yeah, I did regular numbers.
It's a learning experience, and that's why I didn't say anything before you did it. I wanted
Well,
you
I
to
made-
do this and go, this sucks ass. And then you'll be like, oh, this is pretty smart. I'm gonna remember
I
this.
know it's so
When I made the graph, I only put down the points that were full integers instead of fractions.
Oh yeah, they're really hard to graph too. The math isn't fun and the graphing sucks too. So -1/2 times -4 is +2, then +2 is 4. So I've got -4 and 4. 0 is easy, it just kills that fraction. I'm left whatever's added, the y-intercept is 0, 2. We've got, if I stick in -2, I've got times -1/2 would be 1, 1 + 2 is 3. And it looks like every 2 I go, this number on the right is dropping by 1, right? As this goes up by 2. So for like a straight line with no exponents, I can speed this up a little bit. But if you stick it in, you'll see that that's what you get. And it's worth double checking one of them just to make sure that you didn't get too hasty. So -1/2 times 4 is -2, +2 is 0. So that works. So let's sketch out the graph. You want to put arrows on the axes to show that they keep going outward. And you want to label. You want to put X on it and you want to put Y on it. Because as you go further down the sequence, if you can go into calculus and beyond, sometimes you don't use the same letters there. You'll do different stuff like T. You might have a Z or other things, so it's worth labeling them. And now we'll just start plotting points. Negative. Look at this shit. I didn't draw enough points. Who let me do that?
I know, I saw it.
Fail. -4, 4 looks like it might be about there. -2, 3 is there. 0, 2 is there. 2 and then 1 and then 4 and 0. So this is the line y equals -1/2 x + 2. We will go over this more today because we're covering slope and this rate of change idea later.
I was about to say,
That -1/2 I can write two ways. I can put -1 on top or 2 on bottom. Or I could put 1 on top and -2 on bottom.
And exactly the first 2 years, right? Just like-
Yeah, so if I start here at the. It's crossing the y-axis, so this is my y-intercept. Since it's crossing the y-axis. I can go. The top one is our y movement and the bottom one is our x movement. So if I go with the 1 in top, -2 on bottom, I can go up 1 and left 2. Up 1, left 2. If I do the other one, I've got down 1 and right 2. Down 1 and right 2, and you can just keep doing it. This is for linear equations. And like I said, we'll be doing more of this later today. You guys are getting an early jump start on it, because that's how I roll. I don't want you to always assume it's that way though, so why don't we do y equals x squared minus 4. That says plus, I wanted minus. Ooh. That is not pleasant. You should be happy that you're a good 15 to 20 feet away.
Sense. I know there's a way you can find the slope. Just like that. But I know.
This one does not have, you do not want to do slope on this one. The slope changes from point to point.
Yeah, because I saw that.
So, remember I said this slope idea works when the exponents are 1. We have an exponent of 2 on the x, and it's going to kill that idea. We will cover ways to do these graphing of like things that like a square function like this. We will cover ways to speed that up. Well, right now we're just practicing graphing it. Since there's no fraction here, I just want to do 0, -1, -2, and +1, +2. And if I stick in 0, the y-intercept will pop right out, 0, -4. The convenient thing with the square functions is that whether or not I stick in -1 and square it or +1 and square it, the outcome is going to be the same, at least with this setup. 1 squared or -1 squared is 1, 1 minus 4 is -3. So -3 will be my y component. My x component is given by the first column. Let me do that here with the -2 and +2 as well. In both cases, when I square -2 or +2, I get 4, and 4 minus 4 is 0. And it looks like it's going. I don't have any positive numbers. I didn't read the room very well right here. I didn't look at my values before I started doing it. I don't need anything in the positive direction. Oh yeah, yeah. I just hadn't gone far enough. 0, -4 is down here. And now I'm going to radiate outwards from this middle one because I think you'll find it handy to see how it's going. When I go -1 or +1 from that spot right here, I go up 1. And if I go -2 or +2 from that starting point, I go up to 0. 1, 2, 3, 4. 1, 2, 3, 4. So it looks like it curls a little bit. The line is coming down like this, and as it gets closer to here, it curves. It's got to start coming back up. This is called a parabola. And it stems from x squared. It comes with x squared functions. And the basic changes, we will be doing this more later, but with x and y, as I go plus or minus 1, y is x squared, it goes up 1. If I go plus or minus 2 squared is 4. And that's why we did 1, 1 and 2, 4. If I do plus or minus 3 squared is going to give me plus 9. So if I go out 1 more over here, 1, 2, 3, 4, 5, 6, 7, 8, 9 would be up here. And it's just related to the square thing. So if you're just squaring the simple 1, 2, and 3, and you know where this, the bottom or the bottom in this case, sometimes it's the top. If you know where that is, you're just going outward and upward, or outward and downward from there. And we'll see it again, but I figured while we're doing it, I might as well hit it more with you. If this was negative x squared, the parabola opens downward. So the negative makes it go down. This was positive, so it went up on both sides. Ready for more? How about the folks online? Y'all good?
Yes.
Okay. Let's take a look at circles. We'll do a little bit more with circles. Remember, the general form of the circle is this. Where the center is HK and the radius is R. And notice that these HKs are positive, so the center is the opposite signs of these. To get the center. So we'll do our first example here. What you always want to do first is identify the center and the radius. So what'd you guys get for the center? It's 1, 2. And the radius? 3. So the center isn't actually part of the graph. So just make a small little mark for it because it just doesn't really need to be there. But once you have the center, go up and down, left and right, whatever your radius is. So my radius is 3, I'm gonna go up 3, put a point. I'm gonna go right 3 and put a point. I'm gonna go down 3, put a point, and I'm gonna go left 3 and put a point. And then drawing a circle is just a matter of practice, trying to make it so it doesn't look like a shitty egg. It's not the best, but it's not too bad. Give it to you in a different form. All right, so how do you guys feel about this equation right now? Confused? Why?
Not sure. I don't know.
That four's fucking this up, isn't it? Why don't we get rid of fractions? See what happens if we get rid of. If I multiply both sides by that 4. And then distribute it to each one here. It's gonna cancel out that denominator and give us this.
I think we just should do two things. So,
I did. So I really made it 4 times x plus 3 squared over 4.
yeah, I thought we were using thousand. I wait, so it would be like 4x plus.
If I do, then it's the 4 is still gonna be multiplied in every single one. I'm gonna have to factor it out later to simplify it. So like getting rid of it there helps. So where does that put my center and my radius at?
What are they using?
The radius is 2. And -3, 1. Excellent. So let's see, -3, 1 is left 3 and up 1. And from there, I'm gonna go 2 in every direction. God, that isn't a good circle. Looks skewed. Give me one more to do. Here, we just wanna get it set up. Just find it and get in the right equation so we know what the information is. So remember, we gotta complete the square for each of them. I'm gonna put some space in there. And I'm gonna move the 1 over to the right by subtracting 1. Bless you. So I should end up with x something squared plus y something squared equals something else. We just gotta figure out what we gotta do to get there. So what we're gonna do is we're gonna take the 6, we're gonna cut it in half, and we're gonna square it. 6 cut in half is 3. That'll be what goes in here, 3. And then 3 squared is 9. So I'm gonna add 9 here and add 9 over here. Same thing with the -2. If I take -2 and I cut it in half, I get -1. I'll put -1 here. When I square it, I get +1. Holy shit, I randomly pick numbers and end up with a radius that's good. When I add up the right side, I get 9. I got lucky.
That says -2x, so isn't there no other y?
Oh shit, that should have been a Y, my bad. Okay. So if you did it the other way, this was meant to be a 2y. If you actually did it the way it was written, you should have combined the 2 x's. And we would have had 4x and then y squared equals -1. So if you had done it the way I wrote it, which was not what I intended, but I fucked up. We cut that in half and square it, and it's 4. There's no y term to cut in half, right? So it's a 0. If you want, you can write 0 in there. But there's nothing else to add to the right side. But don't leave the 0 in when you're done. So this one you would have the radius is what? It's not 3. Tricked you. What?
Is it 1?
No. You guys know what the radius is here? Online?
It's the square root of 3.
The square root of 3. Remember the radius, this right side is r squared. We have to take the square root of it. So the radius is going to be the square root of 3. And my center would be it's -2, 0. Don't let that throw you off. If there's nothing there, it's a 0. What about up here? The way I had wanted to do it, but I just didn't write it that way. What would the center be up here? What? 3?
Oh,
You're sure? You liked +3 a second ago. Are you sure?
Yeah.
Good, because that's what it is. What about the radius?
3.
It's 3 here. Don't forget to do the square root. All right, it's 3 o'clock. We'll put that on pause. Stop the video so it makes a separate video.